In this unit, we are looking at matrices and networks, and then after that, we'll look at some circuits and paths. Just as an introduction, matrices is a regular arrangement of numbers in rows and columns. So we've got our rows here, and then our columns go up and down the page. So we've got some information here. We've got Geelong has 12 goals and 10 behinds. Hawthorn has 11 goals and 15 behinds, and so this can be shown in a matrix where we have rows and then we have columns. Also in this unit we do some more complex matrix operations, so we can add some information together, we can subtract it, we can multiply, and then we get probably to our more complex matrix multiplication where we need to use all of our skills that we've learned in the past. Simply, a network is formed by objects that are connected. Okay, so we could draw a network from this information of a road network. We can draw a network relating to computers, a rail network, and we could even draw connectedness between our friends in a social network. So a network might look something like this, and we're going to be doing some different types of graphs that are represented in this way. So one of these dot points could represent, for example, town A, and then all these different towns, and we could look how they're connected. At the end of the unit, we're going to be looking at some bigger problems. For example, Conisberg Bridge problem. Is it possible to make a tour of the town of Conisberg, starting and finishing in the same place and crossing each bridge once? So you could start here, can and is it possible? And we'll work out if that is the case. Another typical problem that we might have with a network is this one with a postman. It's called the Chinese postman problem. A postman must travel every street of a city network delivering letters and finish at the same depot that he started at. How can he do this in such a way that he minimises the total distance he covered? So say the depot was here, and we would look at ways that he might minimise his travel but do all the roads. You'll get skills to work this out. If you're a travelling salesperson, someone who sells things from town to town, maybe a pharmaceutical rep selling a drug to different doctors and they're going to different towns, how should he or she's route his journey so that his overall distance is minimised? So we'll look at distances between two places, and by adding them up we can work out which is the quickest way from home back again. We'll also look at the shortest path in a network. What is the shortest path between 2 points in a network? For example, if we start at a car park, you can see here that it's 20 units here to the lone cabin, or it's 12. So I would pick this one. Going from the brink to the quarry is 10, to four ways is 15. So I would choose this one. So picking the shortest way to get from point A to where you want to go might look something like that. You'll get the skills to be able to do this. You might have a puzzle like this. How many ways are there of getting between two places in a network? So we would work out what that might look like by actually taking the original diagram and turning it into a network, into a circuit, and using the rules that I will give you, you'll be able to work out possibly where the shortest pathway may be.